So I'm really happy to have been invited. I'm currently not only in the sociology department, but the chair, and I've been turning down a lot of invitations to do things, but this is a conference I didn't want to pass up. It feels a little bit like leaving the kids at home for the weekend with a babysitter, and I get to go talk to adults. So I'm really happy to be here, genuinely. So while I knew I wanted to come to the conference, I wasn't sure what to present. My own work in progress in the moment, I've sort of strayed off into mathematical demography. Sort of on the I find mathematical demography interesting, but I'm distraught that sociologists don't seem to know enough math to keep pushing mathematical demography forward, and somebody should be doing it. And so that's the stuff I've been doing at the moment. I couldn't figure out any way to sort of spin that for this conference, and so I'm going to back up and talk about a few things that are published already that I've done in recent years, which I hope are relevant for, we'll find out how well they link up to some of the other talks. So in particular, I'm going to, I thought of presenting a couple of recent papers I've got on intergenerational transmission, which is transmission of traits from parent to child. One is in a recent paper in an economics journal. One's a recent paper in a sociology journal. I guess Mike already told you I was trained as an economist. I've now been in a sociology department for a dozen years, so I sort of think of myself as a mathematical sociologist anymore. When I write a paper, it's not always obvious if I'm going to send it to an economics or sociology journal, and usually the rule of thumb is if somebody's optimizing something somewhere, it could go to an economics journal, otherwise it's going to go to a sociology journal. So the first paper, right, is parents making an optimization decision about how hard do they want to work to socialize their kids. And then the second paper being more, I guess an economist would think of as a more mechanical model of fixed transition matrix and thinking about population projections. So the models differ in that one is a one-sex model. I've only learned something about demography in the last few years now that I've started working on it, and it was really surprising to me that most of the work that gets done in demography is with one-sex models, that it's, there's a parent that has a child, and you completely punt on the fact that, it takes a mother and a father to have a kid. The model's much simpler. One-sex models are linear models, and we know a lot more about them mathematically. And for lots of purposes, they're perfectly fine. But for things like transmission of cultural traits, it really is important, if the mother and father can potentially have different traits, to think about how their traits interact and determine the trait of their child. And so again, you can get a long ways with one-sex models. I hope you learn interesting things from them. That's what I'm doing in the first paper. But I guess where my heart is at the moment, the reason I'm doing mathematical demography is to try to push forward stuff on two-sex models. And so you see a simple kind of two-sex model in the second paper. Now, while I'm advertising, I'm going to talk about both of these things. I don't know if that's true or not. So I actually put together slides to talk about both of these papers. But I also think we might be here for 2 hours if I did that. And so I'm going to go through the first paper, and then if there's any time at all, I will do a little bit of hand waving about the second paper. And the second papers, they're mostly, I think the first one probably connects better to the conference, and the second one is just there to, again, flag this issue of, one of the limitations of the first model is it's a one-sex model, and that's my mission in life at the moment, to try to get demographers to think harder about two-sex models. You could use either of these models to study population dynamics of religious traits. And so it doesn't really show up in either paper, but that was in the back of my head for both of these papers when I first started writing them. That's been a very long-standing interest of mine. Why are some religions bigger than others? What governs the dynamics of the distribution of the population of across religions? And so I started working on, the first paper you'll see is an extension of a model by Vista Verde, with the idea that I was ultimately going to do some sort of empirical application to religion. Vista Verde themselves give religious traits as one application, ethnic identity as another possible application. The second paper, you can sort of see from the title, has The empirical application is actually to transmission of racial classes, right? So given the racial class of the mother and the father, societies have different rules about what's the racial class of the child, and then you can project ahead and see what's going to happen to the population given fertility rates and given the rules about racial transitions. That might seem much more of a stretch for this conference, but from a formal perspective, it's a two-sex model of transmission, and so you can be given a lot of applications. And in fact, it doesn't show up in that paper at all, but the reason I started working on that was to think about religious transmission. And there's a sociologist of religion, David Voas, who has an interesting paper a few years ago on secularization in Great Britain. And his argument is that he thinks what went on was it used to be the case that if the mother was Church of England, even if the father wasn't, the kids would become Church of England, and that's what sort of perpetuated the Church of England for a while. But at some point there was a crossover, and so then if only one parent was, then the kid was no longer in Church of England, and that sort of was what the downfall of the Church of England was. And so I thought that was really interesting and wanted a formal way to come at it. And so I actually started writing this model with that application in mind. And along the way, I got sidetracked by a colleague who was interested in racial change in Puerto Rico in the early 1900s and said, yeah, I've got a model that I can do that. So it wound up with a very different application. But I started into that because I was really interested in these questions about population dynamics of religious traits. Now, having said that, it's not clear to me that my interest in population dynamics of religious traits is the same thing as the topic of this conference, the evolution of religious and social norms. Because I'm aware there are lots of different ways to think about evolution of religious and social norms. Some of them have to do with intergenerational transmission, some of them don't. Arguably, norms has something more to do with the content of religion rather than the popularity of the religion. I don't know, but we'll see to what. So I guess the way I said, this is what I've got. I hope it connects up with what other people are doing, and we'll find out. And then, having never thought before about trying to package these papers together, it turns out to some extent, the directions for future research are sort of similar because both of the models, I'll discuss the parameters of the models, and they have to do with what are the distances between different groups. And in these models, those distances are given exogenously. And maybe the interesting question is, how do those distances themselves evolve over time? And maybe that has something to do with, the content of the groups, and maybe that has something to do with their norms. So. Okay, so again, I may or may not get to say much about the second paper. What I'll do is mostly focus on the first paper. So this is, again, I apologize a little bit for presenting published work. I don't think I've ever done that before, but it seemed to me this is the best thing I had to try to link up with the people in the room. So what I'm doing is taking a model that was developed by Vista Verde. They themselves are building on others, Boyd and Richardson and Cavalli, Sforza, and others. And so they have a series of papers. There are a bunch of people who've now applied the Vista Verde model to lots of different things. It's about, as I've already said, the transmission of cultural traits. So the sorts of applications that they had in mind are religion or ethnic identity. But again, judging from the empirical applications of the model, you can apply this sort of model to lots of different kinds of cultural traits. Okay, so what's our key idea? And this is what makes it an economic model rather than a sociology model. It's that parents are making they're choosing socialization efforts. They can decide whether to try harder or less hard to socialize their kids. Right? So in contrast to a lot of simple sociology models of intergenerational transmission, we're not going to take the transition probabilities as fixed, but instead it depends on a choice that the parents are making about how hard to work to socialize their kids. To try to get them to adopt the same trait that you have. So you're going to see this model is going to be set up in a way where it's implicit that if I belong to a certain religious group, I would like my kids to belong to that group instead of joining some other group. And so, so sorry about, right, so sociologists will talk about socialization. Okay, now, sort of amazingly, Vista Verde have gotten a very long way using only the two-trait version of the model, and there's a very special result that comes out of that I'll get to in a few minutes. And hadn't ever really until recently, finally in their iJet paper they tried to do a little bit about going beyond what if you have 3 traits in the population, or an arbitrary number of traits. And it struck me at the outset, if I was going to use this model, that's really important to nail down. Is the intuition you get from the case with 2 traits much different than what you would get from the case where there's an arbitrary number of traits? And so what I set out, my goal was, well, let's think about their model in the more general case where there are n different traits. So my observation is, so here I'm trying to sort of summarize what you're going to learn from this paper. Given a particular specification of the socialization cost function, right, so again, parents have to decide how hard they're going to work, and so there's some cost, and so there's some functional form implicit in that. Using what's probably the simplest, if not the best specification of that, you get a result that the Vista Verde model turns out to be equivalent to an evolutionary game under replicator dynamics. So a few slides from now, you'll see an equation that you'd say, if you came in and you're an evolutionary game theorist, you didn't know what I had talked about up to that point, you'd say, oh, that's the replicator dynamics. And so that's going to be one point. And once you realize you're working with replicator dynamics, then we know a whole lot. So mathematical biologists and game theorists have proven lots of results about replicator systems. And so we can immediately apply a bunch of results that we know in that context. So again, this is a one-sex model. So a parent has a child. Again, if I get to it, I'll advertise for, I think we really should be using two-sex models. And some of the Vista Verde stuff, they actually have thought about how to have built a two-sex framework, but I'm just going to use the one-sex version of it. So the population is partitioned into these different traits, or I'll interchangeably say traits or groups. So I guess that is important to flag, because you could be coming in with the idea that, well, people have got lots of different traits and you're a package of traits, and so you're some element of the power set of traits. But that's not the way they're thinking about it. So you've got there are n traits in the population and you've got one of them, right? So think about religion. It's not empirically true that everybody has one and only one religion, but by and large, most people would indicate a single religion, and so that's the way to think about this model. So you've got some distribution of the population over the n traits, and then there's a two-stage socialization process. And again, sorry for not throwing in all the sites. I don't know to what extent they're borrowing this from Boyd and Richardson or from others. But the way the two-stage socialization process works is, I guess the way to say it is, parents get first crack at their own kid, right? So you figure out how hard you want to work to try to socialize your kid, which is to get your kid to accept the same trait, to adopt the same trait that you have. And so that occurs, so I'm a parent with trait I, and I wind up socializing my kid to my trait with probability DI. If that fails, right, so I get first crack, but if I fail, then what's going to happen is my kid is going to go out and draw from random somebody else from the population, right? So the terminology here is oblique socialization, or alternatively you could say they draw a cultural parent from the population. So randomly, given the distribution of traits in the parent's generation, they're going to pick somebody and they're going to adopt that person's trait. So the transition probabilities, I'm a type I parent. What's the probability my kid adopts trait J? Well, two things have to happen. One is I had to fail, right? So that's 1 minus D. And then he had to bump into somebody with trait J, and that happens with probability QJ. On the other hand, what's the probability that my kid adopts my own trait? So I'm I, my kid adopts trait I. Well, that can happen in two ways, right? It could either be that I succeeded in socializing him, or I failed, but it just so happened that he picked a cultural parent who's like me anyways, right? And so there's sort of a second chance for my kid to adopt my trait. Even if I failed, he may draw a cultural parent like me. And so this is, so for purposes of intuition, this is what's going to be really important for the parents' motivation. How hard do I want to work, or do I not? How hard do I not want to? I guess I don't know if I should give away the punchline of the paper right now, but it's if you're in a population where everybody has trait I, I don't need to, I have trait I, I don't have to work at all to socialize my kid to trait I because I know they're going to draw a cultural parent like me anyways, and so why put in any effort? Whereas if I'm a small minority, pretty much the first shot is the only shot I'm going to have, and they're not going to pull a cultural parent like me from the population. Okay, so ultimately the D's are going to be, I'm going to make them endogenous, right, as a consequence of the parent's decision. But to write down the population dynamics, let's first assume that they're exogenously given. So given discrete generations, right, so there's a really simple model where you live one period and you die, and your kids live one period and they die, and so on and so on. So the population dynamics are given by this. What's the proportion of people with trait I in period t plus 1? Was just all of the trait J, and what's the probability each of them send a kid to trait I the next period? I'm assuming, actually I guess all the slides you're going to see are based on the assumption of one child per parent, but there's an easy generalization of this model to allow different traits to have different reproduction rates. And it's actually, if somebody reminds me later, I can talk more about that. It turns out you stay within the framework of the replicator dynamics, and it's just a different interpretation of what the cultural distaste parameters are. And so if you can make me go back to that later once I get to that point in the talk. But for now, just to fix ideas, imagine that each parent has exactly one child. So here we're just rewriting the equation. So this would be in discrete time, the difference equation. I'm moving the continuous time because most of the results we know about replicator systems are for continuous time replicator systems. And so if I'm going to go to the literature and start stealing results, it's easiest to have a continuous time formulation. I think the older I get, the more comfortable I am just saying, hand waving, saying, yeah, it's a good approximation for that. So the continuous time model is a good approximation for the discrete time. If you want to be more careful than that, I was in the paper, right? So you can actually write down the discrete time dynamics in such a way that if you take limits, you get this continuous time equation. Or maybe I'm more comfortable with this just because since I do a lot of network analysis, I read the physics literature a lot. And physicists do this all the time. It's like, well, here's a model we want to study, and here's a model that's almost like it, and this one's a lot easier to work with, and so we'll do this. And so if it's good enough for physicists, So anyways, that's the, we'll work with the continuous time specification of this. Okay, so at the moment, the D's... yeah, so that's where we're...
And is it that hard to do that in a discrete system?
No, it's not that hard. It's just more work for me because I'm not much of a mathematician. I'm just stealing other people's results. So I mean, I think most anything you're going to prove about the continuous time system goes through in the discrete time case, but nevertheless...
stability by not.
Excuse me?
Stability by not.
Okay, fair enough. Yeah.
Just following up on Simon. Simon did a wonderful paper with us a few years ago on the benefits of being discrete.
Oh. So I walked into something.
In biology,
D-I-S-C-R-E-T-E.
discrete, yes, not discrete. In biology, they made bad mistakes by going to the continuous case, like using backward, forward, diffusion equations, and taking limits in arbitrary ways. And if you do it discretely, you get better answers.
So
Even the physicists
I don't think anything I'm going to tell you today is going to hinge crucially, but maybe you'll tell me, right? So once you see the results, yeah. So I mean, to the extent I have stability results, and in fact, I don't even know that I brought those slides along because I was trying to pare stuff down. It's stability for the continuous time version of the model rather than the discrete. So fair enough. You can, for stability, you can run into issues.
Was more realistic. One might argue that the continuous model is more realistic.
Well, all of these are an approximation to, so this discrete time thing where I live a period and die, and then my kid lives a period and die, but the yeah, I'm off in mathematical demography at the moment where everything's age structured, and all of these are very crude approximations to really having an age structured population. So yeah, all of these things are just approximations of, what demographers would really want to use. Okay, so if I stopped at this point and just made the D's exogenous, this is not a very interesting model. So I mean, if you stare at that equation for a minute, what you can convince yourself is that whichever trait has the largest DI, so whichever parents are best at socializing their kids, that trait's going to rule the world, right? Eventually everybody's going to adopt that trait, and so this just isn't all that interesting. So what makes it interesting is if we give parents some ability to choose how hard they're going to work to socialize their kids. So we're going to make the DIs endogenous, and so the way Vista Verde set this up is to, so a parent with trait I is going to choose DI. So notice so I keep saying you're choosing effort, but the way that they model this is you're directly choosing the probability DI. So this is the expected benefit of your kid. So Vij is I'm a type I parent, I'm going to have a type I kid, and Vij is how do I feel about that? What's the value of that kid to me? And then you're just taking an expectation over all the different kinds of kids I could have. So it's the expected value of my kid. And then we're subtracting off, this is my cost function, right? So the harder I work, the more costly it's going to be. And so the optimal solution is, equating marginal costs and marginal benefits. This is what you get. And what turns out to be important for the marginal benefit side of it are these differences here. So this is the difference between, so I'm a type I parent, my kid could be I versus my kid could be J, and how bad is that for me, right? So if it's really terrible for my kid to be type J, then this is going to be a big number. If J is almost as good as I, then that's going to be small. And so from here on out, instead of carrying around these VII minus Vij terms, I just use delta Ij to talk about, so Vista Verde call these cultural distastes, right? So you're in group I, how much do you dislike? How bad would it be for your kid to adopt trait J? Right, and so you can see in the case delta II, that's just VII minus VI, so that's 0. So so that's the best thing that can happen. But and then depending how much you dislike trait J, these could be Vij can be 0, could be positive. Okay, so to simplify a little bit further, so here I'm allowing an arbitrary functional form. If I'm a very, very applied theorist, right? And so the first thing you want to do is, I don't want to do that. I just want to pick the simplest functional form I can think of, right? So the simplest one you can think of is 1/2 d squared, because if you take a derivative, the 2 comes down, you cancel, right? So that's going to be really easy. So, and in fact, Vista Verde, they do the same thing in the IJET paper. So they pick that particular functional form. And once you do that, then you get this optimal solution, right? So di star is equal to, right? So you can think of that as the expected distaste of potential cultural parents. So I look out at the population, and I think if my kid draws a cultural parent at random, how bad is that going to be for me? And so, so that's how to think about this equation. Right, so it's interesting to note that the parent's choice depends both on the current composition of the population, right, these Qs, and it also depends on the, the cultural distastes, right, so the deltas. Right, so we should worry a little bit about corner solutions here, right? So one of the downsides of using this functional form is it doesn't constrain D to be between 0 and 1, so we're going to have to put some conditions on something to make sure that happens. So one way to do that is to make all of the delta ij's less than or equal to 1, or a different way that may be more satisfactory is to throw in another socialization cost parameter, and I do that in the paper, but I won't bother you with it here. Okay, so so a couple slides ago, I gave you the dynamics where we're thinking that the D's were fixed, and so that's this equation. If we now substitute in for the optimal solution, we get this ugly thing, and then we can rewrite that using matrix notation in a slightly more elegant way. And so this is the point if you walked in and didn't know anything about what I was doing, you might look at that equation and say, gee, I know that equation, that's the equation for the replicator system, right? So the interpretation in game theory is delta is a payoff matrix. Delta Qi, that's the expected payoff to people playing strategy I. Then you're subtracting off, this is actually just a scalar, right? So that's the average payoff for the population. And so if your trait is doing better than the population average, the quantity in brackets is positive and your trait is, more people are playing it. If this is negative, if your trait is doing worse than average, then your trait is going to, then fewer people are going to play it. Okay, so we've sort of going through making this special assumption on the cost function, we wind up with the replicator dynamics. And yeah.
There is a, the way you model it, there is a conscious choice of the rational choice of the parents about which religion is going to their child, his child is going to have, right?
Yeah.
But if there is this, usually in these models, there are some adaptive dynamics, right? I mean, players are not really conscious of the costs they are. If you make the agents conscious, don't they? I mean, the parents should take into account that other parents make the same reasoning, right? And if he's taking into account that other parents are doing the same reasoning, then it becomes a coordination game, and with all the strategic uncertainty that it implies.
I think. Right. So your kids are picking cultural parents from the parents' generation, which is fixed. Right, so I mean there'd be a more indeterminacy if you're picking a cultural parent from from your own generation, and then that's going to lead to a lot of complicated stuff about multiple equilibrium stuff. But I don't.
I'm not. There should be some kind of coordination game among the parents, which are choosing the best. The effort to put in conditioning, socializing.
Well, I don't think that's the case, but I'm not sure how to answer it. So let me keep pushing forward, and we can come back and you can see what the problem is with what I'm doing or how I might answer you. Okay, so once we get to the equation for the replicator dynamics, part of this is just to step away and say, gee, that's neat, right? That I didn't know the Vista Verde model had anything to do with the replicator dynamics. And so you could say, it's as if instead of having n traits, there are n strategies. Instead of having a cultural distaste matrix, you have a payoff matrix. Instead of the Vista Verde story about parents are choosing effort levels, individuals are updating strategies, and usefully stable long-run equilibria in the Vista Verde model, we're really looking for a Nash equilibria of this game. Now, the restriction here in terms of evolutionary game theory is we're thinking about a payoff matrix that has zeros down the main diagonal. So if any trait is matched with itself, you get 0. And then if you're matched with any element off the main diagonal is non-negative, right? So you do have these conditions on the payoff matrix, but other than that, it's you can think about this in terms of evolutionary game theory.
Jason,
Yeah.
Do the cultural parents also choose effort levels?
No.
Why is that?
Because the model's too simple to allow anything like that. So I mean that'll be one thing I say a few slides from now about. Well, okay. So if I back up to my motivation for going into this, I said I'm starting out. My motivation for this paper is to figure out what happens when we have more than 2 traits. But if I'm more honest with you, what was my original motivation? It was to sort of jazz up the choices that are made by parents and or cultural parents and allow a more complicated socialization process than this very simple 2-stage one that I came up with. Now, on the way to getting there, I got sidetracked doing this, and so I still haven't gotten back to the problem of let's make the socialization process more complicated. But that might be a way to go.
Is that a difference with the evolutionary models that only a subset of the players can take?
I don't know how to answer that. So I mean, once you start thinking about this as an evolutionary game, you have a whole way of thinking about evolutionary games and an interpretation you bring to it. But if I didn't tell you all this stuff, you can continue to think about the model in terms of the Vista Verde models. Just at the end of the day, the models just come out to be, the math comes out to be equivalent. I guess that's a way to think about it. Yeah.
I think both of the prior questions rest upon the type of transmission that Vista Verde choose, and that's this oblique transmission, not horizontal transmission. And so when the parents types are fixed in the previous generation by their socialization, and that's one generation. And then they decide to socialize their children. Now, when their children are matched with others, they're matched with the parents' generation, not with their own generation.
Correct, right, that was my...
The coordination issues.
Right.
And then also, that also means that the cultural parents types are fixed. They're just determined by the socialization in the generation before them.
Right, so thank you. I think that's what I was trying to say before, and I think maybe that's the right answer to Michael's question too, so thank you. Okay, so Vista Verde, many of their papers only focus on the two-trait version of this. And once we're talking about the replicator system, this is the path matrix in general. This is there's a unique globally stable equilibrium where some share of the population plays strategy 1, some play strategy 2, and you can think about this. So let me say it differently. So the interesting thing about this model is, unlike the simple case where the Ds are exogenously given, it is not the case that one trait will completely take over in the long run. Instead, what we're going to have is an interior equilibrium where both traits survive in the long run. Of course, the proportions pulling the two traits depend on the cultural distaste parameters. So if group 1 really dislikes group 2, then delta 1, 2 is big relative to delta 2, 1, and so you get something closer to 1 here, or vice versa. But nevertheless, what's interesting is that there's an interior equilibrium instead of moving to one of the extremes. Now you can think about that in a couple different ways, right? This is the intuition coming from Vista Verde that, well, what's happening is as your group gets bigger and bigger to taking over the population, the effort of those parents would go to 0, because you'd say, I don't need to exert any effort if everybody's like me. My kid's going to become my trait anyways. Whereas, that small minority is realizing, we have to work, the only way we're going to transmit anything to our kids is if we work really, really hard. And so that's what keeps that group from becoming extinct. Or, you can just think about this in terms of the evolutionary game theory now. We've got a path matrix where matching to your own trait gives you 0 payoff, and so it can't be, so we're going to have an interior equilibrium rather than 0 or 1. Okay, so qualitatively we get this result. We have an interior equilibrium, but nevertheless the relative distaste of the two traits does affect their shares in equilibrium. So one of the things I do in the paper, and this slide was on the bubble of whether I'd have time to include it or not, but is to think about try to give an exhaustive analysis of the 3-trait case. And so this is what the generic path matrix would look like. And it turns out the way that I tried to characterize it, these psi terms turn out to be what's important. And I realize I'm throwing a lot of math at you. But the intuition is, I think of these things as invasion conditions. So when psi 1 is positive, that's saying if the population was only made up of traits 2 and 3, could trait number 1 invade the population? And so, I guess I did it differently here. So suppose we're at the 2-trait equilibrium with trait 1 and trait 2 having the equilibrium shares. Suppose nobody initially holds trait 3. Would it be possible for trait 3 to invade? Well, the condition is when this psi 3 thing is greater than 0. And I guess the reason for throwing this math up here is, when would that be the case? It's the case when trait 3 has enough distaste for the other 2 traits, right? So when delta 3, 1 is big, right? Trait 3 really dislikes trait 1, and when delta 3, 2 is big, trait 3 really dislikes 2. So as long as you dislike the other 2 traits enough, you can get a foothold in the population and grow. But if if those numbers are small, then psi 3 is going to be negative, and trait 3 won't be able to invade. Yeah, you don't need to see that. So, well, I guess. Let me just, I'll do a bullet point version of that. Okay, so what's interesting is when you move from the 2-trait case to the 3-trait case, there are 2 possible outcomes. One is you could have only 2 traits persist in the long run, or you could have an interior equilibrium with all 3 traits persisting in the long run. And so that's something that's qualitatively different than what you get out of the 2-trait case, right? The 2-trait case, you always have an interior equilibrium, whereas in the 3-trait case, it may or may not be the case that all 3 traits hang around in the long run. And again, the trick is all 3 traits, right, goes back to these psi terms, if all three of these psi terms are positive, if each of these traits has enough distaste for the other traits, then they'll all survive, but if they don't, then one of them will go away. And this is accomplished in the paper just through a bunch of examples. What happens as n gets bigger, so once you get to n at least 4, you can have multiple equilibria. Once you get to n equals 5, you can have limit cycles. So the dynamics are way more interesting than you might have expected just on the basis of the first few papers that Vista and Verde wrote. So part of the again, having recognized that there's this equivalence of the Vista and Verde model to the replicator dynamics, one of the nice things is we can now steal results from evolutionary game theory and apply those to this model. And in particular, my colleague, I guess I'm not giving him any credit on this slide, but my colleague Bill Sandholm has a new game theory textbook, which if you haven't read, everybody should. And so once I got the punchline of this paper, I started leafing through his book trying to steal every possible result I could. And so the trick is there are special cases of the cultural distaste matrix which satisfy some conditions, either a condition called a stable game or a potential game. And in those cases, Bill and other people have proven results about global stability. And so Vista and Verde spent a whole paper doing a whole bunch of simulation analysis to show a result that when you've got this specification of the cultural distaste matrix, that you get a unique equilibrium which is globally stable, but I can sort of do it in one line by just citing Sandholm's result. Right? And so what this says is delta ij is equal to delta I for all j, so that's saying there are some traits that are haters, right? So you hate every, I'm trait 1, I have an equal dislike for trait 2 and trait 3 and trait 4 and trait 5. Trait 2 on the other hand may be a nicer trait, right? So it has a lower distaste, but it's fixed across all the other traits. And so in that case, right, you can prove that the path matrix satisfies this condition of being a stable game. So it has a unique Nash equilibrium, which is in the interior. And so, I don't know, I don't want to go through the other ones, but the point is there are a bunch of interesting special cases of the Vista and Verde model, special cases of the cultural distaste matrix, where we can use these results to prove things about global stability. Connections to mathematical biology, and again, I now feel even worse I didn't cite Bill because Bill was the one who put me onto this. So he said, well, if you're doing this, there's a whole literature of mathematical biology on the replicator system, and probably they know a lot of interesting things that you could import too. And so it turns out that biologists have realized how hard it is to analyze the replicator system, to completely characterize the replicator system once you've got n traits. And so what they've focused on is the simpler question of not what are all the equilibria going to be, but rather will every trait, or in their case it'd be every species, will every species survive in the long run? So if we start out with n species, will all of them be around in the long run, or will some of them go away? And so in a sense, it's sort of the question that I was addressing in the 3-trait case. Or in their language, is the replicator system permanent? And so they've got necessary and sufficient conditions for permanence, the invasion condition. So what are called Janssen's inequalities in the biology literature are actually just a generalization of my psi conditions on those invasion conditions. And that if those are true, that implies permanence, or if a system's permanent, then there's a unique interior rest point. As a bonus, there's actually a literature within biology on what are called catalytic networks. And this is not only about replicator systems, but it's replicator systems with the precise structure of the payoff matrix that you have in Vista and Verde, right? So it's zeros down the main diagonal, and all of the off-diagonal elements are non-negative. And I'm going to do a really botched job if I try to explain what the biology application is, but my understanding is it's they're thinking about prebiotic evolution, right? So they're thinking about how do molecules combine to make bigger macromolecules, that would then allow biological evolution to take place. And so the idea is some molecules catalyze, some molecules are important for catalyzing other reactions. And so you have a whole network of these catalytic chains. And so they've, it's sort of interesting, maybe not interesting to you, but interesting to me since I do a lot of stuff with networks, that a lot of the results in that literature are actually based on the graphs of the delta matrix. And so you're not thinking how large are the cultural distastes, but simply whether they're zero or whether they're positive. And sort of amazingly enough, you can actually prove a number of results solely on the basis of knowing this directed graph. And simply, I guess it's, I don't know, I guess it reminds me a little about Markov chains. You can learn a lot about Markov chains just from the zero patterns, even if you didn't know anything about the probabilities. And so it's sort of the same case here. Just knowing the zero pattern of the delta matrix, you can actually prove a bunch of results, even if you don't know more in particular about the delta matrix. Okay, so I've got a few minutes. I've got no hope of telling you anything coherent about the second. So I've got a bunch of slides, but you're not going to see them. So let me just conclude on this one. And again, since you're not going to see all those slides, what was the point of that whole other paper that I could have presented to you? It's just, among the things that are too simple in the Vista Verde model, or the version that I've worked with, is the one-sexness of it, right? And it. For lots of interesting applications, I think it really is important to realize, kids have two parents and they could have different traits, and how do those traits combine to produce the kid's trait. And so that's, if I'm going to keep going with the Vista Verde model, or if other people are doing it, I guess that'd be one of my leading suggestions for what you should be doing. Okay, but let me give the discussion of that paper. The key parameters in the model, actually for the model version of the model you've seen, the only parameters in the model are these cultural distaste parameters. I could go back to the point asked about earlier. It turns out that if you bring in differential reproduction, that actually feeds into you could think about it feeding into the cultural distaste parameters. So that gives you a different interpretation of what cultural distastes are. Partly they're based on true distastes, but partly traits where parents have more kids also have higher cultural distaste parameters. So there are two things feeding into what makes the cultural distaste large. It could just be, it could be a true distaste, or it could be you have a lot of kids. And so I'm not showing you all those slides, but you can see the paper to see that. What I'm not allowing is endogenous fertility, right? So that's going to complicate things a great deal more. But if you assume that each trait has some exogenously given fertility rate, you can stay within the framework of the replicator dynamics. Okay, in any case, those are the key parameters in the model. And what's the key result of the model? It's that, from an evolutionary perspective, it looks like it's a good thing to really dislike other traits, right? So that's what comes through. You're number one, it causes your trait to be permanent, right? So to not go away in the long run, and then conditional on that, it's going to improve your long-run population share. Thinking about it like that, you go, well, I don't know, something's missing in this model. That can't be true, because I can think of lots of societies where, the most popular traits are not necessarily the nastiest trait, the traits that, dislike other traits the most. And, you start to think, well, what's left out of the model that could account for that? And I don't know. I guess one hunch I have, and this goes back to the kind of line that Michael started to go down, was to think harder about how should we specify the socialization process, and in a more elaborate way than this two-step process that I had. So for instance, I don't know, neo-Nazis, right? So neo-Nazis hate everybody. I'm not too worried about my kids becoming neo-Nazis, right? And it's not just that there aren't many of them in the population and they're not likely to sample them as a cultural parent, but it's probably that if they do happen to bump into a neo-Nazi, the neo-Nazi beliefs are so different than what they know about that there's no chance that they're going to adopt that person as a cultural parent. And so, you could start to think that maybe if you have a trait that's so far out there that hates everybody else, it's going to be really hard to serve as a cultural parent for anybody. And so, you need a model rich enough to capture that sort of thing. And that might give some evolutionary advantage to nicer traits rather than to the nastier traits. And then, everything I've done today is contingent on these cultural distastes being fixed, right? And so that opens up a whole other interesting question of how would those things potentially evolve through time? And to be honest, I guess I have ideas. I'm not convinced any of them are good ideas. And so I'm not going to voluntarily offer any of them to you. But, it could be, I think maybe what's important is to, instead of taking as a primitive these cultural distastes, which are essentially just giving you distances between different groups, it's sort of important to unpack, well, what are these what are the content of these traits? If we're thinking about religious groups, what are the norms of the groups, and to what extent do they conflict with the norms of other groups, and sort of unpack, how do we derive those positions in this, the distances between these groups. And so, to the limited, my limited thinking about it, maybe that's a way to go to start thinking about how to endogenize, how to think about the evolution of the cultural distaste parameters themselves. So I've got 3 more minutes left, but I'm just going to stop here. Herb.
2 points that are related.
Yeah.
It's not surprising you get a replicator dynamic, because when you derive the replicator dynamic, whether it's biology or culture, you're always having agents bump into other agents and switch to their type with a certain probability depending on various parameters. That's not surprising. But an interesting point is, if you shift to a network, instead of saying people randomly bump into each other, that they're connected together by a network where the probability of meeting other people is whether you're linked to them at all and how powerful. Then you get a generalization of the replicator dynamic. Okay, you get a generalization of the replicator dynamic. Now that's a technical point, but the substantive point is one of the major ways in real societies that people invest in the cultural, in the socialization of their children is by changing the network parameters. Like you live in a community where most people, go to church on Saturday, and your kid never bumps into anybody who doesn't go to church on Saturday. So this separation of, DI, you assume QI are constant, but the DI, you can vary. But one thing you can do is you have QIJ, that is people are linked to other people, and your investment is in the linkages that you make. And those can be costly. You move to a community where, incomes are lower, but everybody is civil to each other, et cetera, et cetera. So I think the network idea fits together both with the replicator dynamic and the substance of how cultural change and reproduction really occur.
Thanks. Peter.
So it's interesting to think about the differences between the models that Rob and I made for years compared to what you made. In almost all the models we've made, the costly decision making is on the part of the offspring, not on the part of the parents. The parents in most of our models are just passively imitated by learners, imitators with strategies of various kinds that we've modeled. So it's obviously both things are true. You alluded to thinking about needing to put some decision making in the offspring in your last few sentences. So the question is, how much difference does this make? How much parallelism does it lead to?
Let me ask you about when you were working on those models. So you took this to be of second order importance. Think about the parents' choice, and why was that?
Well, I don't know. That's a good question. So
no, I don't mean to put you on the spot.
Or the other, right? It's pick your poison, I guess. We did do a little tiny bit with, and I've done a little bit since with models in which the parents become active decision makers and active socializers, and just a couple little things. But in those cases, it looks like a special case of the offspring active models. I can explain it to you over coffee or something.
Okay.
But I'm not sure that we didn't do anything in general to try to see if there are fundamental qualitative differences between those two ways of going at the costly decision making, or whether it all comes out in the wash in the end and they look very similar. I just don't know the answer to that question. As far as I know, nobody does.
Okay. Steve.
I just want to make some comments in favor of James's model and also Herb's
remark. My wife and I put a lot of effort into raising our children Jewish, and the reasons were precisely and very consciously the ones included in the model. The social distaste was we didn't want to have Christian children, and the population state was we lived in the South where everybody was Christian. And one of the methods was to manipulate the network so that a lot of their friends were Jewish. That wasn't the only thing, but that was an important one.
And how did it work out?
It worked well. The thing was, we put zero effort into converting somebody else who wasn't Christian to Jewish, and we never observed anybody Christian putting any significant effort into converting our kids.
Yeah, you remind me. So Vista Verde, I have a bunch of papers, and some of them co-authored with Giorgio Topa. And when I've heard him present versions of these papers, the example he always uses is he's Italian, living in the States. He really wanted his kids to love soccer. And in Italy, you can send your kid out to play in the street, and they learn to play soccer. You know, but in the U.S., it takes a whole lot of effort. And he's got to be a soccer coach, and you do everything possible. And so it's sort of his, his application of his model. So it sort of reminds.
No.
I don't know if his kids are old enough, right? So I don't know what the outcome is. I heard him give this paper a few years ago. So.
If you want to know whether it worked, ask me in 10 or 20 years.
I don't remember your name. I'm sorry.
Oh, I'm Jacob.
Jacob.
So I was also, I guess, follow up on Herb's point. I was also struck by sort of the lack of an explicit term for offspring choice or decision making, which I see a lot in my house. And is that going to influence the model a lot? I mean, one thing for sure is maybe your initial sum would be up to J plus 1, because you've got the possibility that they'll just invent their own tree. Every once in a while, people make new religions or something like this, and that a lot of the decision making is going to be sort of bottom up from the offspring themselves. And again, taken from within my house, I might say that term could just be a random variable of a certain size you could throw in.
Yeah, I mean, one thing to say in general is, this connection between Vista Verde and the replicator model. I don't know how far you can push extensions of the Vista Verde model before this falls apart. And what I tried to do in the paper, I was very, very happy to learn that you can incorporate exogenous fertility into the model without breaking that link. But what I suspect is once you start messing around a lot with the socialization process, then it's going to be much harder to keep the link here. But forgetting about that link, it's certainly important to complicate the Vista Verde model in different ways. Michael?
Yeah, a couple of suggestions which I clearly I don't mean to suggest that these suggestions are criticisms at all. On the contrary, I think this is a very useful model for what you're trying to do. But these are some directions that one might also go. Two things. One is not just having cultural parents, but cultural siblings. That if one's trying to understand this intergenerational process, the influence of cultural siblings is going to be important. Not one's own real siblings, but the peers out there. And that brings me to the second, which is to possibly look at a class of models like the PAC model, in which you have traits, but you also, again, following up with her, you also have edges, and the edges have valence. And that valence could either range from 0 to 1, depending on the strength of the top. I think the strength of the valence could be -1 or +1, and the strength could be 0 to 1 in absolute value. So you can have cases where, let's say, the cultural siblings, the peers, cause you to flip the sign of the tide of the parent to negative, so that now you're trying to differentiate from your parent and to do the opposite of what it is that they're trying to tell you to do. That, I think, does go on in the world.
I've got 2 teenagers, yes.
I can vouch for that. Because Filipino children refuses to talk in Tagalog outside. There are occasional Filipino kids who will be fluent in Tagalog. But Hispanic children speak Hispanic outside fluently. And no matter what, the Filipino children will be linked.
So,
And also these models, as here, they have, the mathematics have been really well worked out for POTS, for Ising models, for Hopfield models. So there's a whole literature there that you could then be able to tie into if you were to go into that direction.
It seems like something that might be missing, if you want to tie this to religion, more of an extension would be institutions, and particularly institutions that try to affect QI, the probability system, so through proselytization. So for example, the Mormon Church is very good at this. You're much more likely to run into a Mormon in a lot of places than there are Mormons in the population, and can't do the mathematics in my head, but it seems like that might allow for a process where a small cult actually, or a small group of people actually becomes quite.
yeah, I mean, in a sense, this paper is sort of, I sometimes think of the anti-Larry Iannacone paper, which is, Larry's all about, institution, small group, I'm sorry if I'm mischaracterizing you, but small groups, right, have this huge incentive to, especially when they're not state supported, to proselytize. So it's all thinking about the religious professionals and what their incentives are. And so there's a whole, Larry and Stark and Bainbridge and Finke and a whole bunch of people. So the emphasis has been entirely on organizations and what they do. This is moving way over to the supply, the demand side rather than the supply side, and thinking, well, there is sort of a parallel thing going on with parents choosing effort, but there's no reason we can't bring both of them together in a model. So, yeah. Sorry if I miscarried. Yes, Larry.
I'm doing a paper where people just muddle around in a matrix, an agent-based model incorporates some of these kinds of effects. And acknowledges, as somebody pointed out, that not all ties are equally strong, can get you some interesting results, and in particular the persistence of subgroups that you can begin to analyze what distinctive features are most important in keeping a subgroup alive. Whether it's reaching out, proselytization, proselytizing, or especially effective socialization or some mix. So I agree. I think a lot of these traits are not maintained by self-conscious institutions and groups so much as they are by often very self-conscious parents.